All right. Well, sorry for the delay on getting this one started. Um, Ended up having a few technical issues. Um, Tends to happen when you do these things, but so far so good. So just kind of getting things started here. Um, got a few things organized, make sure the connections are stable before we get too started. Hopefully people start coming in here, checking this out. Today's live stream will be HMI to PLC communication. Trying to get our panel view plus 7 to talk to our PLC control, our compact logics PLC. So again, today we're going to use the 5380. Has been working pretty good for us. It's one of the newer compact logics. Very, very efficient, very, very fast. So we'll just wait a few more minutes here for everybody to get in here. All right, and as always, feel free to subscribe and follow the YouTube channel. Also, you can check me out on Instagram. We'll be doing some short video clips on Instagram as well. Try to get things kind of rolling from that perspective. Try to keep everybody informed on what's going on. All right, so without further ado, let's get things kind of kicked off here. So today we are going to be focusing on the HMI communications to the PLC. I'm not going to spend a ton of time on actually programming the HMI or how to add buttons and all those kind of things. We will add a few just to verify and check that everything's working and set up properly, but we're not going to spend a ton of time on that actual side of things. We can do another live stream later on where we'll do more of an in-depth into programming of the HMI, how to do different things, how to set up things. If there's a specific question, I'll be more than happy to address that today. But as of right now, that's kind of the plan, is to really just talk about how do we get the two to communicate together. And in order to do that, we actually don't do very much on the PLC side at all. Almost all of the communication setup is done on the Panel View Plus itself. So we don't tend to have to do a lot on the PLC side because the panel view will actually dig into the tags of the PLC and pull that information out, rather than the PLC being in charge of those things. So the HMI actually uses the Ethernet communication, goes in, looks at the tags, and can read and write those tags accordingly. So we'll do a little bit of a dive into that to talk a little bit more about how that looks and what we do. So let me flip over to the hardware here. We'll have a quick look at what hardware we are using today. So again, you'll see that we do have the 5380. So the 5380, we are going to use the L306 ERM, mostly because that's the one that I've already got hooked up. It just makes things a little bit easier for us. It does have the dual port Ethernet on the bottom here. So we have A1 and A2. Currently they're set up as dual IP, so individuals. We can set those up and do what we need to with those. In the middle, again, you'll see that we have an Ethernet hub. The Ethernet hub is very important in this aspect because the PanelView Plus really does require an Ethernet type communication to the PLC, and we can utilize that Ethernet connection to push the programs in, to download the programs to the PanelView Plus, and to actually transfer that information back and forth. We also have the actual PanelView Plus itself. So today we'll be using the PanelView Plus 7 standard version. This is a 7-inch that I have got mounted to the board here. So we're going to use that for demonstration purposes. Really, all of the PanelView Plus 7s are relatively close to the same, right? How they look, how we program them from an ME perspective, machine edition perspective, is pretty standardized, right? We've got a bunch of buttons on here. We can load the applications. We can reset, run the applications. We can do some terminal setups, and we'll talk about how we actually start things off from there. So again, as we going to go through this hardware, if you have any questions on the hardware side, please let me know. I'd be happy to answer those questions for you. Try to get a better understanding of, from the hardware perspective, how do you set one of these things up. This particular screen is a 24-volt DC power supply screen, so it only uses 24 volts DC. There are 120-volt versions that you can purchase as well. But for my application, we're going to use 24 volts. We also have an Ethernet connection on the back, which allows us to communicate to the PLC. There's some USB ports on the side. You can use USB to actually transfer the data to the PanelView Plus. You can do firmware upgrades that way. You can actually transfer your applications. And it's just an extra step. And not all the time should we be opening panels up to get into the panel views. So that's why it's ideal that we use Ethernet communication to download and update all of our programs on there. So a couple things that we're going to talk about first when we get into this panel view. Down here, it's going to be probably a little bit difficult to see. That is actually the IP addresses of the unit itself. I'll see if I can zoom in a little bit here and get a better picture without as much glare, maybe. There. You might be able to see that a little bit better now. So we've got our IP addresses and our subnet mask on the HMI as well. Those are important. Without setting up the IP address, you're going to have some difficulties getting anything to talk or anything to transfer across. So in order to set those up, we have a couple different options. You can actually plug a keyboard, a USB keyboard, into these devices and have that use the keyboard to navigate, but that's highly unlikely. It's going to be very rare that you have a keyboard hanging out in your toolbox. Maintenance guys just typically don't have keyboards lying around. So typically, we're just going to use this straight as a touchscreen. So the first thing we're going to do is go into terminal settings. And under here, you're going to see a whole list of different things. We've got alarms, diagnostic setup, display, input devices, print setup, startup options. How do you want this machine to start up? What's the time and date? What's the system information? There's a bunch of information that you need to know in here in order to be able to actually create the programs and do different things. So there's two areas that we're going to focus on today. We're going to focus on the networks and communication, and we're going to talk about system information. Those are both two very important things in terms of setting up HMIs and setting up the communications with those HMIs. So the first one we'll use the down arrow key, get to networks and communication. So network and communication, that's going to be our first one that we want to go to. Once we go in there, we're going to see four other selections. You got KEP servers, network connections, RS-Link enterprise communications, and LDAP configuration. For us, we're going to look at the network communications. The network communications is how we're going to set the IP and the subnet mask. And then we have another four choices here. We've got device name, network adapters, network identifications, and network diagnostics. For us, we want to adjust the network adapter. The network adapter being the NIC or the network interface card that's inside of this unit that allows us to communicate to other devices. So here you're going to see we only have one network adapter installed on this one. There are other PanelViews and other PanelView types, so you can have more than one adapter set up, but we only have one, the Allen Bradley built-in Ethernet adapter. And so here we're actually going to go down here to the bottom. We have three different selections: name, servers, IP address, and settings. So we're going to go into the IP address settings, and this is where you would actually set your IP address. So here you're going to see that we're set to 192.168.115. For our IP address on this panel view. We're also set up on the subnet mask to 255.255.255.0, so this makes sure that our device is on the proper subnet with the other devices that we want to talk to without causing too many headaches for us as far as a network communication. You can also set up your gateway here as well if you wanted to. We're not going to be using a gateway. We have a small little setup here, but this is capable of setting up gateway communications as well. Down in the bottom left-hand corner, you're going to see the MAC ID of this device. So if it's important for you and your IT department, you want to make sure that you get your MAC ID sorted out or stored, so you know what device on the network is what. If you have any firewalls or any kind of higher level IT architecture controlling or activating down on your controls network, you want to make sure that the MAC ID is logged somewhere for that. Up in the top right hand corner, you'll see that we also have the ability to use DHCP. So this does have the capabilities of running a DHCP. Now, we don't have a DHCP server, so I'm not going to run it in DHCP. I much prefer to hard code the IP addresses for our devices. The advantage to hard coding our devices is that from a troubleshooting perspective, we always know that if this IP address is the IP address for the panel view, for example, 192.168.115, we know that if we need to find something, we need to replace something, we can put it onto that same subnet and use that exact same IP address. So there's some significant advantages to hard coding IP addresses. DHCP is a little bit easier. You just plug it in and allow something to communicate to it, but it's much harder from a controls perspective to actually set up two-way communications between devices if you have something automatically assigning your IP addresses to it. So we'll get out of here again with just like we had talked about the VFDs. You want to make sure that after you set your IP address that you power cycle. If you don't power cycle, you're not going to be running the proper IP address. And the way you can tell if you're running the proper IP address is back here at the very beginning, you're going to see your IP address down here. If it still didn't update from that in that little box down there, that means you didn't power cycle. If you've updated your device driver information, you want to make sure that you power cycle so that this updates and this shows your active IP address. The second thing we need to do on HMIs for Allen Bradley is go into terminal settings. We're going to go down to system information. Now, why we have to go to system information, and then we're going to go to about FactoryTalk View ME. What's important when we get into this area is the version number. So the firmware version number of this screen has to match the runtime application that we create with the software. This is extremely important. You cannot push a runtime, a different runtime application of a different version into another panel view. So you have to be able to match that major revision. So in this particular case, we are going to be running ME Station 9.0. So we have a major version of 9 on this HMI. Now again, we'll talk about why, and I'll show you where that's important. But it's very important to grab that information from the panel view, because as you pull a panel view out of your stores, or you're replacing it, or you've got a new one from a supplier, you need to make sure that you have the information for that individual HMI so that you know what the runtime is that it's running. Right? So you can see that there's a lot of other information here as far as version numbers, what ActiveX it's running, what display drivers it has, what kepware it's running, all the fonts that it's running. There's a bunch of information here. The one that's important from us from that perspective is the ME Station. So again, to get to that, you go to System Information, you go into there, you go into About FactoryTalk ME Station, and from there you can find the actual version number of the device itself. So we're going to go back to this main screen here. I'm going to just adjust the camera slightly to get you a little bit of a better shot. Hopefully it doesn't cause too much glare, although that does look pretty rough. Let me see if I back off a little bit. There we go. That looks a little bit better. So again, we're not talking too many details on here. After we set the IP address and we've put this on the network, we're basically good to go. Question came in, what do I mean by runtime? The runtime application is the file that we create in the software. So we're going to talk about that here in a second. Runtime is a type of file that we create in FactoryTalk Studio that incorporates everything on the device. And that runtime file is what we transfer to the HMI in order to have it run an application. Right? So we have a runtime application, it's called, that we push into the actual HMI. So we're going to talk about that because that's integral to how do we program and how do we set up an HMI, because that runtime is the key program or key file that gets transferred between the two of them. So let me switch over here. Let's go back to the main. You guys can check out the desktop again. So for today, what we're going to do is we are going to end up using what's called FactoryTalk View Studio. There's a bunch of different installs. Rockwell has tried to streamline and clean things up a little bit on their installations. You'll see here that FactoryTalk View Studio actually incorporates what used to be two different types of software. We've got Site Edition and we have Machine Edition. So Machine Edition is what we're going to use for this panel view. So most panel view pluses that you see, or all-in-one hardware devices, they are what we classify as Machine Edition. That Machine Edition is basically a hardware device that runs the application. Now, what you'll see is different with Site Edition. Site Edition is computers, right? So we could actually run FactoryTalk View Studio or an HMI type software on a computer, and then we have different ways to run that. We can run local station, right, which would be the computer that you're working on, or we can run network station, which would be a network type computer, or a network distributed, which would be that the HMI would actually be hosted somewhere else, and then we can actually run that from different screens. So those are different ways that we can run the FactoryTalk View Studio to allow us to kind of be more versatile in our application. All right. So from here, we are actually going to pick Machine Edition, right? Because that's obviously the one that we're going to run. We're running an actual HMI, a physical panel view plus. So we're going to run Machine Edition, and we're going to hit Continue. Inside here, you're going to see a list of all the existing programs that we have. You can see there's a bunch in here. There's going to be some information. But for what we're going to do today is we're going to actually make a new one. Right, so we're going to call this HMI demo. Right, we could put a description in here if we wanted to. We can set the languages. Again, there's tons of languages selections here. We're not too concerned about the language at this point. We're going to run English. And then the resolution, this is how or what type of device we're using in order to better understand the resolution of the actual screens that we're trying to make. So what we have here is a PanelView Plus 7 standard, but you'll see that standard and performance are kind of the same. So we're going to select standard. We want our MER file, which is our runtime file, to execute on a PanelView Plus 7 standard. There are differences between a standard and a performance, so you want to make sure you select the right one. Performance obviously has more features and more things available to it, but for us, we want to run just the standard for this application, and you're going to see that the MER file is what we're going to create to make that runtime. So at this point, we're going to hit the Create button. You're going to see a bunch of things popping up down here in the messages. Certain things become active. We start to look and pull out to get our project servers. We're going to start to create the software architecture. You'll see it populate over here in the Explorer window. You're going to see a whole lot of stuff show up in order for us to be able to create this file. So I'm going to get rid of my face for right now, and hopefully we can get back to seeing what this Machine Edition is going to do for us here. So you're going to see a whole architecture side here. Now I'm running version 11 of FactoryTalk View Studio. I believe they are up to version 12 at this point. You can have older versions. The version of the software is less important in HMIs when programming HMIs than it is in PLCs, right? In PLCs, we know we have to have the same version of software as we have on our controller. That's very important. And what you'll find with HMIs is that when we go to create this runtime file, this file that runs the application, we can actually pick the version that we want to create. So we can create anything less than the version of our software. So I'm running version 11 of FactoryTalk View Studio Machine Edition. I can make a 10. I can make an 11. I can make a 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 in theory. Right? I can make any of the lesser versions to make sure that that application runs. Now, one thing I can't do is make a higher version. Obviously, when I'm running version 11, I can't make a version 12 runtime. So you have to make sure that at least you have the newest or the highest level in your plant or your facility in order to be able to run that. Now here you're going to see a whole lot of information about the actual HMI, and there's tons. You can spend hours going into this software, figuring out what it can do, what its capabilities are. We're going to talk about a few key areas, but again, we'll cover this later in a later live stream about actually what each one of these things do. One of the first things you'll see here is the project settings. This is kind of the systems folder. This systems folder is really where you set up kind of that overarching control systems. So if we look at the actual project settings, here you're going to see where we specify the Panel View Plus 7, Standard Edition, executing on a standard, the size and the width and the height of the actual window. We can see some runtime information. Do we want a title bar? Do we want borders? And what to do during inactivity, right? What do we want this to do at different times? So you can see that there's a lot of setups that you can do there. We can also set up runtime securities. If you want to add passwords, if you want to add users or logins, you can set all that stuff up here. Different security codes and security levels if you wanted to. You could do some diagnostics. Another one that's pretty important is the startup. When we start up, what's the main screen that we want to do? What are some optional screens? What's the initial graphic, if there's any parameter files? And we'll talk a little bit about parameter files later. Underneath that, you'll see the HMI tags. So you do have the ability in this software to create tags internally that are linked to an application or a tag in a PLC. I don't particularly think that that's a great idea, although there's pluses and minuses to everything, right? So what I tend to do when I create a link in my displays is I actually go directly to the PLC tag. I don't use an internal tag in FactoryTalk View and then connect that to a tag in the PLC. We'll talk about the differences in those and some pluses and minuses a little bit later. Here, the graphics section. So in the graphics section, this is where we will actually create our graphics, right? So we've got our main screen. You can see here, we've pulled up our main screen now. This is where we'll add our buttons and our words and our different things on there. We can also have global objects, a symbol factory. How do we make symbols? There's a library of all kinds of different things that you can add to your screens. We have images that you can add. You can see there's a ton of images in here of different things. These are already predetermined images that come with the software itself. Your parameters and your local message files. This is basically how we're going to create our graphics, how we're going to have things operate and run in our software, right? How it's going to visually look. We have an alarm setup, so fault codes, alarms, status updates, those are things that we would set up inside this alarm setup. Alarm setups are very important to help actually track things down. So we can set the triggers, we can set the messages, we can do a lot of different things. What bits turn what on? There's all kinds of stuff that happens inside the actual alarm setup. And that's very good to know how to set those up when you're doing an initial machine install. We can do some information, some macros, some data logging, and some recipes, all within the HMI as well. Now, one of the key areas for us right now is this FactoryTalk links, because inside FactoryTalk links, we want to do this communication setup. That's obviously what we're here for, is to make this HMI talk to our PLC. So the first thing we're going to do is double click on the communication setup, and it's going to bring us a configuration wizard. We're going to want to create a new configuration. If you already have a configuration file or a runtime configuration, you can import that. So you could import that if you wanted to, or you can copy a configuration that's already running on the workstation. So if you already have an existing workstation that's already communicating to a PLC, you can copy that from that workstation and pull it onto there. What we're going to do is actually use this create new configuration for right now. You're going to see this pops up another window here, and this window here is basically our shortcuts. How do we create that device communications? So you can see here that we're starting to populate some of that information of what exists on our network right now and all the drivers that are already installed. So what we're going to do is go up here to device shortcuts, and we're going to add a device. For me, I'm just going to call this PLC. You can add any device name you want at this point. You should probably follow whatever your company standards are. As far as configuration device names, that's very important to stick to standards. And usually you want to call it something meaningful. Like in this case, I'm calling it a PLC because I'm talking to a PLC, so that's important. Up here, you're going to see two different tabs. These two tabs are extremely important. We have design and runtime. Design is how we're going to talk to the PLC locally right now as we're setting this up and designing the screens, right? So in order for me to set up design, I have to know where that is. Now, runtime is slightly different. Runtime is the file that we're going to make, like was asked, what is the runtime file? The file that we're going to make embedded into that has a communications drivers. And what are we going to send to this panel view plus in order for it to communicate to the PLC? So what are we going to bundle into that application, that runtime application, and what are we going to send over to the actual device? So let's walk through that. First off, we're going to set up our design. We know that we have the PLC on Ethernet. Because this is the same PLC that we've been using before, I know that the IP address is 192.168.1.1. Again, if you don't know what the IP address is of your PLC, you'll just want to go online to the PLC, either look at the banner bar at the top to find out what that IP address is, or go into RS Links and find that out. So for our sake, we're going to use this one because we know that that's our L306 ERM. Once you click on that, you want to make sure you hit apply. Once you do that, it's going to say, listen, are you sure you want to overwrite the old shortcut? Now, if we look down here, the old shortcut is blank. Well, obviously that's good, right? We didn't have anything there, so we can overwrite that old path with the new path, which is AB Ethernet 1 to our 5069 L306 ERM. Right, so that's good. Or do we want to apply these changes? Yes. Now that we've clicked that, in our design, as we're setting this up and programming this, we will have no problems communicating to that PLC. The other thing we need to do, though, is also set up the runtime. Now, you're going to see a button over here that says copy from design to runtime. There are some advantages to using that, but there are also some disadvantages. When we copy from runtime, we're going to take everything that we see in this screen here, and we're going to copy it over to this runtime tab. Now you'll see here in the runtime tab, we're very limited in what we have. We don't have anything configured. There's nothing in Ethernet. There's nothing in Ethernet IP. There's nothing in this Ethernet either. So we don't have to, there's not a lot of information there. The problem is that a Panel View Plus can only communicate with one driver to one device, right? On a standard Panel View Plus, one driver, one device. So if I were to go back to the design and copy over all of this information that's here, we would actually have too many things in our runtime, and when we go to create our runtime, it would actually fail. So in order to properly create a singular point in runtime, I'm going to go to my Ethernet, and I'm just going to add a device. At this point, it's going to pull up a add device selection. You know, you could dig through all this stuff if you wanted to, add an Ethernet PLC. There's tons of them there. You know, we could go over here. We can add a SLIC device. We could add an Ethernet IP device. There's tons of stuff here if you want to add all that. What I want to do is I'm just going to do a quick search for a 5069 L306 and hit Find Device. So now you're going to see it jumped me right to the 5069 L306 ER, which is okay, but I need the ERM, right? You have to make sure that you have the right PLC for your communications. Now, when you hit the plus button, I'll make this window, I can't make that window any bigger. You're going to see that it's giving me a list of all the major revisions for that PLC. So it says, what revision of your PLC are you using? So it has that information to communicate. Well, I know that I'm using revision 30. And again, if you don't know, make sure you go online with your PLC. Make sure you understand what major revision you're using. And you're going to hit OK. It's going to say, well, give it a name. I don't really care at this point. You can give it any name you want. I'm going to leave it the way it is. Here, I'm actually going to go and add the IP address. So the IP address of that PLC is 192.168.001.001. Now, you don't have to put those leading zeros in there. You could just type in, 192.168.1.1. Whatever your PLC IP address is, that's what you want to put in there. And then we're going to hit Apply. Hit OK. And then we should see that PLC populate in there. Again, we have to remember to hit Apply at the top. If you do not hit Apply, it will not actually apply the old and the new runtime paths, right? So we want to remove this old runtime target path of blank and replace that with our new PLC tag. So again, you want to make sure that you see this screen pop up, and then you just hit yes. Once you've done that, you've got your PLC assigned to this one. You've got PLC assigned to this one for design tags. You can hit OK. Now, once you hit OK, you're going to see a bunch of stuff populate down here. And if you look at these messages, you'll see that the symbol upload ends successfully. So we're actually getting communications already between our devices, right? Between our our design application, which is what I'm working on the computer, and our actual PLC. So we know we at least have that communications working for us right now. So at this point, we're in pretty good shape. I can see communication happened here at the bottom. I can see the PLC and the design is talking. So I like that. That's good. At this point now, I'm going to add a button. Let's just add a simple momentary push button. All right, so if I look up here, sorry about that, jumped a little bit ahead of where I wanted to be. I'm going to delete that. Delete. All right. Up here, you're going to see a toolbar. This toolbar is where all the things that we can add to our program or to our screen is. There's also other ways to get there. You can go to objects, right? Objects basically is kind of the drop-down menu for all of those different devices that you can put into your screen. Or what you can do is just hover over top of these if you don't know what the symbols are. But as you saw, as you get better and better and do more and more HMIs, it just becomes second nature to actually go click on one of these buttons and draw down that information. So you'll see that there's tons of different things that you can add, and Alan Bradley breaks those out into different groups to try to create or try to make your program a little bit easier to put together. So let's just go up to objects, and I want to add a push button, right? So I know we're going to go to objects. I'm going to go down here to push buttons, and now we have a bunch of different types of push buttons that we can add. We have a momentary, maintained, latched, multi-state, interlocked, ramp. Some of these names may sound familiar, and this is why during class I push so hard to make sure that you understand what momentary and maintained push buttons are, because when we get to programming and automation, it's very important. Right now, I'm just going to add a momentary push button. So a push button that when I press it, it turns on, and when I let it go, it also releases. Now, when you click, you can see as I click and hold, I can change the size of that button. It doesn't really matter how big the button is. I can make the button the entire side of the screen if I wanted to, or I can make the button smaller. What's interesting is when I let go, it automatically pops up that properties box for us. So I'm just going to move that over here so we can see the screen and everything. This properties box is now very, very important for us. There's a ton of things to configure on these buttons. Before I go too much further, I kind of want to just talk a little bit about HMIs in general. HMIs are one of the things in the automation world that allow you to be truly creative. How you lay things out, the colors you use, the animations you use, the interfacing you use. It's all about creativity at this point. Now, you don't want to make them very gaudy, and you don't want to make them over powerful. There are HMI standards. There are people that have written, most effective HMI use. There's a lot of different literature that's out there as far as how HMI should be programmed and how HMI should be set up and what colors you use. What I always tell people is it comes down to your operators, right? Ultimately, the operators and maintenance are going to be the people who use these HMIs either to run their equipment and or to actually troubleshoot their equipment. So what ultimately is the most important thing for you to set up or you and your team to work on is to have an HMI that gives you the information you need in order to effectively do your job. If that means videos and hyperlinks and animations and crazy colors and rainbows and sparkles or whatever you need, that's fine. What it comes down to is effective use of the device for your job, whether that's troubleshooting or operating the equipment. So please keep that in mind. This is not something that you should be doing in isolation on your own. You shouldn't be making an HMI, not telling anybody, not asking anybody for input. This is really about making sure that it's effective for everybody on your team. So let's go back over here to properties. Now I have a little side tangent there. The properties of this push button are important. this is how we can set up not just the appearance of the push button, but how it functions, right? Is it normally open or normally closed? Does it just write a value? How long does it have to be held for? Does it get highlighted? What are the borders? What are the shapes? That's all in general. We can go over to states. Now we could talk about the different states of the push button, right? Push button not pressed, or the initial state is 0. State 1, if it's a normally open push button like mine is, state 1 would be when we push the push button. We can put the colors here, so you can change the colors and change the patterns, right? All kinds of different stuff. You can make it blink. You can make the patterns a different color. Do your captions and your alignments. There's a ton of things that you can do here. If I want to label this push button, I could put push button into the caption and hit apply, right? There's push button, right? State 0. Let's also add push button into state 0. Hit apply. Maybe I want to make that bold. Right there, state 0, it's bold. Maybe I want to make it bigger. I can make that push button word bigger. I can change the alignment. If I want it in the top left corner for some reason, I can put it there. Back to the center, no problem. There's a ton of information that you can add here in order to make sure that your push button or your device is able to articulate what you want to the operator. Under common, you'll find some more information. The height, the size, right? The height and width of this push button. This is good information if you're trying to make things exactly the same. You could come in here and say, oh, you know what? I wanted this actually to be 65, right? And you'll see the push button will change. I actually wanted the width to be 160. When I hit apply, you'll see that the push button changed slightly, became a little bit smaller. We could change the position, right? So I could hard code the position here. If I want to say, you know what? I really actually wanted this also at 60, but the leftmost position I wanted at 80. When I hit apply, you're going to see that push button physically move on the screen. See it? The whole push button moved. It didn't change size, but changed the actual position. Now, if you wanted to give this push button a name so you could track this down later, you could give it a name. So we're going to call this HMI push button 1, right? So we can hit apply. And it says blank characters are not permitted. Very much the same as when we create programs or when we label things in our PLC, we can't have blanks, right? So if I wanted HMI push button 1, I have to make sure that I put the bottom bracket or the bottom underlines there. Now when I hit OK, you'll see that it updated the name. Going over to connections. Now connections is how we actually make this push button connect to the PLC itself. There's two different things we have. We have a value and an indicator. And a value is bidirectional. You can see the arrows on both sides, so it goes both ways. An indicator will only take the information from the tag and push it to the push button itself. All right, so when this tag is on, the indicators will change what it is or what it looks like, right? And we can see that done over here, the state values. So what we're going to do is we're actually going to hit this three buttons over here on the tags to bring up our tag browser. Now right now you'll see that we only have system tags, right? And these system tags are read-only. They're what exist inside of our HMI demo. We don't have anything on here that tells us about the PLC. So a few different things that we can do at this point. We could just assume that we have our PLC connection and we could just write the values in there. We could manually type them in, square brackets PLCs, and square brackets, and the tag value. The other thing that we could do is actually hit this refresh all folders. What happens is we refresh the tag folders, it looks onto the PLC and says, okay, well, what tags do you have? And so now if I go and I look up here, we'll see that I actually have my PLC. That PLC would be whatever the name is that you gave it earlier, that shortcut name. So if you would have called that PLC mixer or PLC conveyor, that would have shown up PLC conveyor. When I open this up, we're going to see that there's two different things. We have diagnostic items, and inside diagnostics items, we have kind of the standard things that we can talk to the control logics. There's a whole bunch of things here that are just standard diagnostics. Have we added things? Are there changes that have happened? These are basically your standard communication items within the PLC. The other folder we have is online. Inside online, you're going to see that I already made a bunch of tags inside that PLC. Right? So that PLC already has tags that exist inside of it called HMI, HMI push button, HMI reel, and we have an HMI array as well. So at this point, I'm going to actually open up the PLC program. So I'm going to open up Studio 5000. I'm going to upload from the PLC. I'm going to go to USB because that's why I've connected to my PLC. I'm going to go to the HMI demo PLC and I'm going to upload. So inside this online, this is actual tags that exist inside of that PLC. So we're able to already pull all that information up. We can look at the main program, right? So not only are we looking at the controller level, we can actually look at the program level and see that I've created a timer inside of my program level, right? I can see that timer exists. I can see all of that information about that timer, accumulated, done, enabled, preset, timer timing. Those all exist inside that timer. So I could pull that information out if I wanted to. We are going to go online and we're going to have a look at this PLC. So I'm just going to move this over. Inside the controller tags, you're going to see that I've made a bunch of tags already, right? So I have HMI, and inside HMI, if I go back here to online, HMI exists right there, right? So that HMI tag is the same HMI tag I have. I have an HMI push button, which also exists. And I have an HMI array, which is right here as well. Now the array is a group of dints that I've made that I'm able to do some information. So I've got a program running right now that we're going to use for verification of our PLC. I'm going to move this down just for a quick second. Now we're back to the push button, right? So we're working on our push button. I'm going to assign that to my HMI push button, and I'm going to hit OK. So now you're going to see that inside the tag expression, I have PLC HMI push button assigned. If I hit OK, we can close this window out, and we know that the push button is now assigned, if you look over here at the Object Explorer, the Properties Explorer, to PLC HMI push button. Now at this point, we can do some tests, right? We can check to make sure that our PLC is actually communicating. So I'm going to move this to one side. I'm going to shrink this up a little bit just so we can see that. I'm going to open up my PLC program, move it to the other side so we can see the HMI and the PLC at the same time. And I'm going to use this button up here. This button up here is what we call Test Display. Test Display allows me to leave this as it is, but create a quick test and push the button. So now you can see we're in Test Display. If I push the button, right, you can see that my push button, HMI push button over here, if you keep your eyes over here, as I push the button, it turns on. So every time I push the button, we hear a little ding, and the push button shows up as a 1. So that's extremely good, right? That means that my computer, through the design, is talking to the HMI, or to the HMI PLC. So that's extremely good for us. The other thing that I want to do at this point is I'm going to make a couple more. I'm going to make what we call a numeric display. And a numeric display simply displays a group of numbers. So I'm going to pick 6 digits here. I'm going to say, all right, we want a couple decimal places. We could change the pattern, what things look like. I'm going to make a quick connection to this, and I'm going to attach that to my HMI real. So again, a real number is a number that potentially has decimals to it. But once I make this my HMI real, I'm going to actually update the size of this a little bit so we can see it better. Maybe we'll change it to Comic Sans, have a little fun. And we're going to actually turn this on. Now you can start to see that the HMI is updating, but that seems slightly different than the speed of this. You see how this speed, it seems to be pretty fast, and this seems to be relatively slow in comparison. One of the things that gets missed a lot when building HMIs is the refresh rate of the page itself. And this is pretty important. When we right-click on the screen and go to Display Settings, we're going to see that there's specific settings for a display that we want to look at. We can have the display type, whether it's a replacement or just populates on top. Do we want pop-ups? Are there certain numbers that we want to assign to this display? Is it 1? We can have all different numbers assigned to things. What background colors? What are the security codes? But the one I'm just talking about right now is this maximum tag update rate. The maximum tag update rate tells us how often the tags inside this PLC are actually going to update. You can see that it was set to 1 second. So even though I had a decimal place for my timer, it was never actually updating that fast. I have the ability to change this to a very, very high update rate or a very, very fast update rate. The advantages to a very, very fast update rate is the things on the screen will update quickly. I'll be able to get better real-time data. The problem with that is that when we have that tag rate as fast as it is, every single thing on that screen will be pulling on the network. So the network will start to get very much more utilized, and the actual amount of data transferred is going to increase exponentially. So you have to be careful that you don't bog your network down by changing the update rates on everything to the fastest possible setting. For right now, for our purposes, I'm going to show you the difference between that slow uprate that we saw and this maximum tag uprate that we have now. It does give you a warning that says changes to the update rate do not affect the display until it's reopened, right? So until this actual screen is reopened. For our purposes, you'll see here that it's, again, still very, very slow. So what we'll do is we'll close the screen down. We're going to save the changes, and then we will reopen the screen. Once we've reopened the screen now, we go back up here and push play, and you can see now there's a very stark difference between what it's doing now and what it was doing before. What I'm going to do is I'm going to make this a little bit bigger. Just going to change and update the size a little bit more so that when we transfer it over, it's easier for everybody to see. Now we see we got a big number right in the middle of the screen there, updating really, really fast. That's great. At the bottom here, we have a shutdown button. This shutdown button is extremely important as you're trying to set up your screen and make modifications to your screen. You want to always have a shutdown button so you can shut down your application when it gets transferred over. Eventually, you want to remove that because you don't want the operator to be shutting down the HMI while they're doing it. But for diagnostics and troubleshooting purposes, you want to have that. So let's make the assumption here that we're all done. We're happy with the way the display looks. Everything's good to go. We're now going to try to transfer this into the actual HMI itself. So at this point, we have to do what's called creating a runtime application. And to do that, we go up to the applications up here at the top, and we are actually going to create the runtime application. So as you've heard me talk about what runtime is, what the runtime application is, this is where that happens, right? So we're going to create a runtime application, and now this is where things become pretty critical. The name is something that you're going to want to have. It's going to default to the existing name of your project, so that's good to see. The save as type is what's important. Remember we talked last time or a little bit earlier about the actual runtime type and the actual software that exists, the firmware that exists inside the PanelView Plus. This is where that becomes important. As you can see, I'm running version 11, so I can create an 11, a 10, a 9, an 8, a 7. These are all the different applications that I can create inside of this one software. Now, our software, our firmware inside the PanelView Plus is actually at version 9, right? We saw that the major revision was 9. So we have to create a 9.0 application. If we don't create a 9.0 application, when we transfer it over, it won't run. We'll actually have failures on the HMI side. So we want to make sure that we run and create the proper Runtime 9.0 application. Down here, you can put in a few different options. You can have passwords or never allow conversions. You gotta be very, very careful when you're doing this kind of stuff. If you put a password on or you don't allow conversions, if you ever lose the actual application and you want to reconvert the runtime into a software, you won't be able to. So most of the time, we're going to just leave it as always allow conversions, unless you're doing something extremely high tech or extremely has a lot of IP or intellectual property to it. You're not going to want to put any passwords onto it. At this point, we're going to hit save. You're going to see here that the screen's going to flash a few times. We're going to have some things pop up in the top left. It's going to give us a little warning. This is one of the newer things you're going to find. To open or convert a runtime application to FactoryTalk View version 9 or earlier, you have to install a specific patch. One of the things that happens a lot with Rockwell software is patching software. So there are certain things that you need to install or patches that you need to do, especially when you're moving from version to version. So keep in mind all these different things. Use the knowledge base if you have any issues. Rockwell does a good job of tracking that stuff down and documenting that for you. Save changes to main. Obviously, yes, we want to save the changes before we create the runtime. So you see up here in the top left corner, we're actually going to create that runtime. So it's going to take all the graphics that exist in this program, it's going to take all the images and the libraries, all the communications, and it's going to jam it all into a runtime file for us. That runtime file is very important. That runtime file is actually going to be what we end up transferring over to the actual PanelView Plus itself. Again, if you have any questions while I'm going through this, please feel free to shoot them into the chat. Be more than happy to answer them. Or if a question comes up later on, reach out to me. No problems answering those. You can see that creating a runtime file can take a little while. Depending on how many graphics you have, what the size of your files are, what the size of your displays. They're trying to compress it all into a file with doing some verification checks to make sure that everything is actually running the way it's supposed to run. You see here, it's going to run through all the different areas, startup, data log, project settings, all the things that we saw on the left-hand side in the Explorer window that it's going to transfer over to, right? Now it's going to take our graphics and it's going to convert those. It's going to compress everything so the file's not giant. And then it's going to give you results. So it says, yep, everything's good. I did warn you about the runtime application, it says. Validation was complete with that warning. And then, as always, they'll say, if you try to do something that you're not supposed to, running the application might produce errors at runtime. So we're okay with all of that. Now we're back to this window, and it didn't really tell us what to do next. After we've created that runtime, we actually have to use one of the tools that exist in this window called the transfer utility, because we created the runtime on our computer, but we haven't put that over into the HMI at all. So at this point, we're going to run the transfer utility. Now what the transfer utility does is it allows us to take the information and transfer it to a destination. So at this point, we're going to change over the file to our HMI demo that we had. We're going to download that as HMI demo. Here's where you can change the name if you want to. Where do you want to store that? I'm going to store it on internal storage. We do have the option for external storage if you had a USB device that you were storing it on. Run the application at startup, which is very important for us because when the HMI boots up, we don't want it to boot to the configuration screen. We actually want it to run the application right away. And then it says, do you want to replace the communications that already exist on the device or delete the log files? So deleting the log files is generally not a great idea because the log files are there to help you troubleshoot. Replacing the communications, if it's a device that's already communicating to the exact same PLC that you want to talk to anyways, I would not replace the communications. You already know that it's talking to that device. If you have no idea or you just open this one up and it's right out of the box and you're happy with the communication setup that you did in FactoryTalk Links over here on the left-hand side, and you're like, yeah, you know what, I'm good with that, you can replace the communications, but it's not required every time. At this point, now we have to decide where are we going to put this. For me, I only have one PanelView Plus on the network, but you may have multiple PanelView Pluses on the network. Right? So this is the download screen of the transfer utility. That same transfer utility can be used to upload, pull information out of a PanelView Plus, or compare a file with what's in the PanelView Plus. So you can do all of these things from inside that transfer utility and decide which way you want to do that. So for me, I'm going to take this HMI demo MER file, which is the Machine Edition runtime file, and I'm going to download that to this PanelView Plus. So I'm going to hit download. Now what you're going to see is you're going to see a bunch of download screens, right? So this is going to say I'm taking the source from here, this MER file, and I'm going to download it to this destination, which is inside of the PanelView itself. So over Ethernet, right, because we're using the IP addresses that you see down here, we're taking this program that we created and pushing that into the actual HMI itself. So transferring this is very important, and this is what we were talking about when we talked about runtime. Runtime files are key to getting the actual HMI to run itself. Now, as this gets closer, I'm going to flip over to the hardware so you can see what happens when the hardware actually boots up. Because we put run this at startup, we would hope that our screen that we created with the push button and the real-time tag actually flips over. So I'm going to go over to hardware now, and you're going to see that the HMI itself is actually booting up, right? So it did a restart after transferring that application over for you, which is extremely helpful, right? So we're actually able to automatically do that reboot. We are now going to update all the comms, create that runtime file for us inside the application or inside the actual HMI, and turn on the actual program itself. So hopefully here, after it boots up and does its thing, we should see that HMI push button with that real-time values on there as well. Depending on the firmware and the versions of your Panel V Plus, it may take a little bit longer. It may take not quite as long. Here you can see that it says loading the application now. Please wait. After it loads the application, it should pop up with our screen. And there it is. So now you can see that we've got our HMI push button on there. We've got our values updating from the PLC in our timer reel, just like we had on the HMI or on the design itself on the computer. So you can see that we're updating. Looks really good. The refresh rate is good, right? We're seeing things happen fast, which is ideal, right? In this application, I'm trying to look at numbers. I want to see the values of those numbers. So it's very important for us to have that application. So now, once we've got that application done, what we can do is flip back to our software. And here you can see we've got a pop-up that said download has completed successfully. So that's great. You know, we go back and we exit. At this point, everything is done. We've got an HMI communicating to a PLC. We were able to do some basic design work. You know, it's always a good idea at this point to make sure that everything's saved, your screens are saved, you've got your runtime backed up. All of those things are pretty critical for actually creating and running these HMI applications. So hopefully that was helpful to know how to set up communications between an HMI and a PLC. Small variations with different types of PLCs and different types of screens, but generally speaking, that's the process, right? You're able to set up that communication link, make it nice and stable between the two of them, download that runtime into the HMI itself, reboot the HMI, and have the HMI talking to the actual PLC. So if you have any questions, please let me know in the chat. But that's about it. That's kind of creating an HMI and communications between the PLC. Again, there's way more in-depth stuff that you can get into as far as actually setting up more displays and different things, utilizing some of the objects that exist, you know, numeric and string information, so you can put words up. You can do indicators, display navigations. We can jump between screens. We'll cover all that in a subsequent live stream, but this is basically just setting up that communications between an HMI and a PLC. So again, if there's no questions, no concerns, no issues, you know, feel free to comment later if something comes up, or let me know, and I'll be able to discuss that with you. Yeah. Hopefully you enjoyed this live stream. If you have any questions, let me know. If not, I'm going to end this here shortly, and I appreciate you spending some time with me today.